Let's go ahead and get started as folks are coming in here. So thanks everyone for allowing me to present today, and a big thanks to the Python Software Foundation for everything that they do and everything that we can have the privilege of working with them on here at Google. My name is Jason Davenport. For those of you who I have not met, looking forward to some exciting Q&A here in a little bit. But just a little bit about me as we start to get in. I've been at Google Cloud for about 2.5 years. I am currently the head of developer advocacy for our data analytics products. So that includes everything from Cloud Composer, which is a large Python project, to BigQuery, which is our serverless data warehouse that we'll get to talking about here in a couple minutes. And prior to that, I was a practice director for a global implementer focusing on software engineering and cloud data engineering and warehousing for that. In my free time, when I'm not chasing my children, I like to do things in the DevOps space. So as folks here are thinking about how do you do more with your data across environments, I would love to hear how you're using DevOps and DataOps in your processes when you have the chance. So what are we going to talk about today? First thing, we'll cover some of the innovations that we've launched over the past, what I'll call 6 to 12 months, focusing on how we bring more language interoperability to our data analytics stack at Google. We'll talk through some things with data frames, some different components of serverless, and then I will do a couple different demos of each of those things just to make it real for those in the room. And then last, open up for Q&A once it's all over. I'm planning just for those aware about a half hour of kind of content and demos, and then questions from the room we can start fielding as we get into it. All right, how many folks here use Google today? It's about half the room. Always great. I would love to see everyone here using Google at some point. No shameful promotion in that. Couple things just to call out. So I think folks here are aware Google is really a company that has championed contributions to the open source community, and then we do a lot of things with those that then become our products that we actually share with you in Google Cloud and across some of our different things like our ad stack. Folks may remember we actually wrote a paper about MapReduce technology. This is probably back in 2006 or 2007. This became what was then known as Apache Dremel, which is actually the backbone of BigQuery, which is our serverless elastic data warehouse, whichever word you choose to put in front of that. That notwithstanding, there's actually a number of other things that we have worked with the community on and then open sourced and continue to contribute on. Bigtable, for those who may not be aware, Apache HBase is obviously the open source derivative of that. Who here doesn't know about Kubernetes? That's something where we donated essentially our code to the CNCF community. And then we've done a number of things along the way, for things like Dataflow and the Apache Beam community, and then obviously TensorFlow and the learnings that have come from that. So as we think through, how do we continue to bring innovation to market with that, a lot of it is driven from the community like yourself, helping us to understand, what are the things that we can do with our products to make them better, and then making sure that we enable access for everyone in order to actually have that technology available. All right, so let me do a quick overview of BigQuery because that's where we'll largely be spending our time today once we get into it. How many people here have heard of BigQuery and or use BigQuery? All right, so about a third of the room. How many folks here work with databases? All right, I should have started with that question. BigQuery is a large serverless database at its core, and it's bred off the notion that we fully separate our storage and our compute from the layers of the database itself. So what does that actually mean in implementation? It means, first off, you never pay for BigQuery for the compute unless you're actually using it. So the only thing that you're ever actually being persistently charged for is the storage, and that is something that we do behind the scenes using a file format called Capacitor, which is a columnar-based format for data. What does that mean using a columnar-based format versus a row-based format? Well, columnar is a lot faster for analytic workloads. So think of it as like getting the total of all of my sales over a range of time. Columnar is really great for that. Other databases use row-based. If you think of things like MySQL or Postgres, Postgres has a couple columnar things, but those are really focused on how do I pick a record, get a record. So what is Jason Davenport's user value that we may return in an application for that? These are all relational databases, not to be confused with NoSQL-based. We do have some ways that we can integrate with those, but we'll save that for another day. So with BigQuery, I have my storage, I get all my data in. What that means then is I can do all these different compute-based things in order to actually analyze that, make sense of it, and then share it with other downstream, either applications or systems or people in that. We use essentially Google's backplane here, so it's a petabit network. You can do things at massive scale here. We have customers that are running, I think the largest single query that someone has executed is upwards of 250 petabytes. It's very, very large. What that essentially means is that we can scale up to that, but we can also do things on megabytes of data or kilobytes of data. It's really up to you as the developer how you want to bring your data to BigQuery and then how you want to manage it in there. The other thing with that is while we do support essentially a standard SQL dialect, we have a REST API and then we have all of our great client libraries which we support. And that's what we'll be getting into talking about here in a couple of minutes with our Python support and extensions that we've been launching in it. All right. So one of the things that we typically see, and this is kind of what I'll call the history of Google in the process, Google Cloud really started out as a way where you could use an API to do just about anything against a database or another platform or technology that we had. So write a REST API request, execute a get data back. That was great if you were a software developer and you already understood things like how do I interact with the REST API, how do I catch errors, all those different things with it. But what we realized is that how to start really democratizing access to data required us to also add things like SQL. So while we had a legacy version that we essentially was a homegrown one we built, we decided, let's implement a standard SQL version based on ANSI, so it's ANSI compliant. And then with that, we started really democratizing even more access to data because folks could do things like write simple create table statements, write selects, export that data, and then share all the goodness with that. Well, if you think about kind of the community and how things have changed, at the same time we were doing all this work, the other thing that started happening was that the Spark community started really getting active, and we started seeing a lot of growth and momentum, in particular with things like data frames. So for those who are following at home in terms of the very quick evolution of Spark in 30 seconds or less, Spark started off with a concept called RDDs. They were super fast. They were very difficult to build. They moved to another thing called data sets, which were slightly easier to build, but still somewhat difficult to work with. And then they actually ended up on data frames, which is essentially a scalable way where you can use programmatic languages to express what you want to do with data and data formats in that. Let's talk about what's great about data frames. First thing with data frames is they are very easy to test compared to SQL. If you've ever written a piece of SQL before, you know that, well, one, the code tends to be very wet, so you have to repeat yourself for very similar things that may happen. It's also very difficult to catch errors and to actually understand, at a unit level, what's happening, and then how do I, validate that unit makes sense as a part of the system. Typically, when I work with folks on pure SQL pipelines, we're focusing more on integration tests and quality tests than we are actually being able to get down and say, does this case statement work in the way that it's intended to for this very small unit of code in that? Data frames allow us to do a lot more. So first, we can express all of our code using the language syntax of our choice. The other thing with that is that we can actually do a lot more in terms of testing and then integration with that into our current application stacks. So if we think about, how does a data frame enable a web application? We can write our data frame in Python. It can be stored within our application framework. And then all that we need to do is have something that actually takes that data frame and then translates it into our application or our database in order for execution. The other thing that's great about data frames is they work really great with Jupyter notebooks. So for those here who are not familiar with notebooks, those are essentially interactive kernels, which allow you to do things like data analysis in real time. So I can do things like express different functions, maybe look at how I would calculate different fields. And all these things, at least until very recently, were things that I could just run locally and then do within my instance. So with that, really the question is, if you think from our perspective, like how do we make sure that if a user is interacting with a serverless data warehouse, that they can use the programming language and the programming tools of their choice in order to interact with it? So, great lead-in, right? Here's where we start talking about data frame support. So what this really is for us is how do we enable that programmatic access to BigQuery by using data frames and making sure that developers can pick the way that they want to interact with their data in the process. And with that, one of the big things that we've been doing is working with the IBIS project, which is a kind of a large data frame project in the community, to make sure that the BigQuery support here is the best that it can be, and that we're also extending this even further so you'll have in the future very similar pandas capabilities, pandas being kind of a data frame library on top of IBIS or on top of BigQuery in that. So let's briefly talk about IBIS and why it's really useful here. First off, it allows us to express all of our different things as code, and not just SQL code, but actually data frame-like syntax, so we can then test each component. And it's very easy to see if we step through our code, what different things are happening and how am I mutating a table or a row or a column over time. Next thing, unlike pandas, IBIS is what's called a kind of a lazy evaluator. So IBIS will not actually execute our code until runtime. And what's great about that is if you think about typically in pandas how you may be constrained to a node or a set of nodes if you're maybe using an operator like Dask. What's great about using IBIS is that we can essentially hold execution until we get the final kind of query that's going to be executed. And what that means is that we can push down all of that work to BigQuery, make BigQuery do all of our work, and then just get the result set back for IBIS. If you think of this in a production setting, this is where we really start to harness the power of cloud compute, because we can have something that's fully elastic, scales up when a user requests something, but then shuts down at the end once the query is executed, and I can get that result back. Last but not least, and this is as of last week when I was talking with some of the contributors, IBIS actually supports 16 different backends. So what's great about this, maybe you have BigQuery, you have Postgres. You can use IBIS to essentially do the same sorts of expressions across a number of different databases in that process. So I'll do a quick picture here, and then we'll actually show this running here in a couple of minutes. But what you can see here, I pulled up just a very quick Python statement, and then we'll run it here in a second. But what's great about this, there's some stuff up here in terms of the syntax. I'm doing my authentication, all that. But then I'm actually just using Python-based operators here, data frame operators, to express how I want my code to actually be executed. So I'm doing things like casting some of my different fields, extracting different elements of the field, doing some group bys and aggregates. Then all of these things, essentially, I can just execute at the end with a simple execution command of the database for that. All right. So we talked a little bit about how do I start working with data frames, but really with that, if I think of a Python object as kind of a block that we need to execute, the question is, well, okay, that's great, but how do I actually execute my code on BigQuery? Because it's Python, and you told me that BigQuery is a SQL-based interface for that. So the next thing that we've launched, and I believe this is in public preview now, is the ability to actually run PySpark stored procedures from within BigQuery itself. So what this means is that as I build my data frame, I can now just store that code in BigQuery from a single pane of glass. And then I can actually run that PySpark code or that data frame code on an arbitrary set of compute. And what I mean by that is that we can essentially take our data frame code that we have, and we could either execute it on the BigQuery compute side, so using kind of our forked version of Dremel, Or we could actually run this on Spark. So I don't have to take my code. I don't have to reevaluate all of it for how BigQuery would execute. I can just use a serverless Spark instance to run that code. It'll execute. Once it's done, it'll spin back down. And then I get the benefits, essentially, of being able to use all of these great technologies together in the same place. So what does this look like? Very similar to what we just looked at for the IBIS code. I'm just using essentially a decorator block up here where I'm creating a procedure, and then I'm just writing some Spark context code, and I can put in here anything that I want, different libraries or things that are required. But what this allows us to do is to essentially run any code that I need against my data to make sure that I'm getting that analysis and that activation that I was hoping for. All right, so we've started building out some of the different ways we can build Python-based compute. But one of the next questions that a lot of our users get is, I'm afraid of lock-in. Why do I have to put all of my data into the BigQuery-based format? And then, how could I actually get access to that data, but make sure it's in an open format or an open source format where it's something that's a community-driven thing that I can use and leverage. So next thing there. What we've been working on is a set of storage-based technologies, which we call BigLake. And what BigLake allows you to do is to interact with things like Apache Iceberg format for your data. And for those who are curious, Iceberg is what I'll call kind of a variant of the Parquet format. It allows you to actually track things like state within the file. So as I have a table and it changes over time, Iceberg will essentially keep track of the metadata of what's changed, and then will give me essentially the ability to do things like updates or inserts or deletes on the Parquet-based format. So what this really means for our users, or for you following along, is that you can pick whatever file format you want to store your data in. Obviously, there will be some benefits for typically speed and performance if you use the Google format of Capacitor. But if there are reasons for your organization to bring your own kind of files or work maybe with Iceberg across a number of different compute engines, we're bringing that and making that easily accessible to you as the user. And this is just a quick overview of how the BigLake API actually works. And we'll see it here in a demo just with the actual code execution. But what we essentially allow you to do is to either use our file format or bring your own, use streaming, and then we provide a unified API on top of all that for that data access. So here, what the focus is really on is making sure that from your perspective as the end user, this is simple and it's open and it's easy to understand and execute in that. All right. So we have all these formats. We've talked about how we start to transform the data, how we use data frames. The big thing now is, okay, how do I start enriching that data, and then how do I actually get to execute my great Python code that I wrote on my database for that? And so next thing we'll talk about here is remote stored procedures. And so what remote procedures allow you to do is to essentially execute any set of code against BigQuery using something like a cloud function, which is essentially a serverless function that you can run in Google Cloud. And I can take whatever data I may have. In this case, I'm going to select some stuff from a comments table, and then I can execute my Python script against that data just using a remote function in that. So this is really, I think of it as kind of like a Swiss Army knife of the ways you can work with code. I've found this to be very valuable. In particular, many companies and users aren't thinking about terabytes or petabytes of data. You have 50,000 records that you need to augment with something else. Remote functions makes it ridiculously easy to do that because I can just write a function, I can select my data, I can add something else to that data, and then BigQuery will just materialize that as a new table or as the result of the select table, or sorry, the select statement in that. So all this makes it really easy to make sure whatever Python you want to go write or to code, that you can then bring your data to that with BigQuery and make it very easy and seamless from the execution perspective. And then last but not least, one of the most recent things we've actually been working on and launching is the ability to access what we call unstructured metadata as a part of BigQuery. So if you think about things like object analysis or image analysis, you'll end up with a bucket, which is just kind of a logical grouping of objects where you may need to pass in what are the locator records for each of those. What you can now do with object tables is essentially store all that metadata in BigQuery and then allow all the different compute engines to access the metadata and then the binaries associated with that, so in this case the images, to then perform additional analysis on top of that. And we'll see a demo here really quickly about how all these come to life by essentially using remote functions with object tables to be able to use Python to analyze all this data but keep the access management in BigQuery and make it very easy for end users to get to the data within it. Here's a quick thing here. You can see we're doing some house-based analysis. What's great about all this, we have all those objects, but the only thing we've had to do here is actually create an external table, and an external table is just that pointer to all those files. And I think in total it's like 10 lines of code or less. So if you think about all the other processes that you may have to run, we try to make it really, really simple to do this stuff with BigQuery and then with different Python libraries. All right, enough slides because those are fun enough, but code's more fun. So let's go ahead and we'll walk through. First thing we'll start with is how some of the data frame stuff comes to life, and then we'll step through each of these examples and build on that in the process. All right. Can folks in the back see okay? Awesome. All right, so first thing that we're going to execute, you can see that I have some code here that I've created. I'm just using a notebook from Visual Studio Code. But what I've done is I've essentially taken that IBIS script that we're going to execute, and then we're going to actually go through and start to execute this code against some of the different data points here. So all that I need to do, we'll run this first one. My auth did not have to rehappen, so that's great. Sorry, one second, let me pull up. All right, so you can see here, if I come back, we can see that this query actually executed. So I'm kind of using a dual screen method here just to show how is my code actually being formulated and run. What's cool about this is if you think about what we actually expressed using the IBIS syntax here for the data frame, you can see we've used things like mutate in order to actually add additional columns to that data. We've also done some order bys and group bys and aggregates. What this actually does, if I come and look at the query that was executed, is we can see that IBIS took all of that data frame logic, and then it actually went and wrote the SQL that needs to be executed against BigQuery. And what's great about this is that if we think about all those different steps, because IBIS only evaluated and executed at the very end, it was able to optimize the statement so that I would actually only get that result, and I would only incur the charge of running that query once against the database. So from the BigQuery perspective, we can see that we have a couple different records that were executed. One thing here just to call out, because I was running this last night, BigQuery, we also store a result cache. So essentially anything up to, I believe, 24 hours that your user ID executes, if it's the exact same code and there's no things like current timestamp in that, we won't actually charge you again for running it. We just return that result set to you again because we're already storing it in the process. So we can see what's great about that is, I've taken my code, and then what I've been able to do is actually express it, within the syntax. I could add, maybe additional unit tests around this, and maybe I would apply this and say, hey, I want to show my end users, the sum of their sales over the past 30 days, and just have that returned to an IDE or web interface. This easily integrates with my microservices and all those other things behind the scenes. All right, different problem, similar vein. One of the things that's always really difficult is building on top of data, because as I work through these different steps, what we saw earlier was essentially the kind of the pre-built code. And as I'm building, one of the things that I'm typically doing is thinking about, well, is what I did, so the group by that I did, does that actually make sense? Does the join that I wrote, like, did I accidentally, create like a Cartesian product, which is essentially a many-to-many join? What IBIS also allows you to do, in this case, is to use what's called the interactive mode. And interactive mode, based on wherever we actually go on this here, will execute in real time as we're going through each of the steps. So the benefit here, if you think about things like type matches, type mismatches are a very common one. I can essentially kind of iterate in real time and look at these different results. So here what I could do, I'll just go ahead and start running this block. We can see here that I'm creating that hour column here, but what I'm doing is actually just looking at this in real time, so it's actually going and pushing down the execution to BigQuery for each of the different steps that are running through it. So what's really great about this, right, is we're kind of solving for two worlds of things, right? One is, how do I do interactive analysis? The other one is, okay, I did that interactive analysis, like, how do I actually make this a production thing that's going to go run? And we can do it from a single library, just using some flag changes in order to make the process work for what we want to do. All right, great stuff about IBIS, right? Let's talk then about what we're working on at Google in order to extend this even further. So while IBIS, if you notice, looks very similar to a data frame, it is not exact to the pandas functions and kind of the spec around that. So the next thing that we are working on here is how can we actually take that and then make what we're calling big frames, which is a pandas compatible API on top of all these things. And what I'm showing you here, I'm just in a Google Colab, which is a almost serverless notebook that anyone here could go and open and then run against BigQuery pieces. What we're doing, I'm just installing the big frame wheel. But then you can see here that what I'm doing is I'm actually pulling in a data frame using my context here. Then I'm interacting with this with the exact same syntax that I would in pandas. So, again, really the intent here is meeting you as the developer where you are and making sure that whatever syntax we have available is as similar to what you're using to make the product the most accessible in that. So here you can see, once I pull that in, I'm just connecting to my context. I'm reading that table from BigQuery. In this case, it's a taxi trip table. I'm doing things like filtering down based on the number of columns, and then I can also do things like creating subtotals of my data, which I'm just displaying here as a part of the code. All right. More to come on the big frame stuff. Right now, we are still actively developing this, but IBIS, if I didn't mention earlier, is already available for you to go and download today and to start using with these different pieces. All right, so we've done a lot of discussion here about data frames. Let's talk about how we can start to use some of the different execution things within this to make it happen. Next thing here that I'm showing, and apologies, let me make the screen a little bit easier to see, is essentially how we can take those data frames or our PySpark code or our other code and be able to execute what we call the Spark stored procedures on top of BigQuery. So as you can see, what's great about this is I have a few things here where I'm just doing some specifications. This would be no different than if you were working with a Spark job, maybe providing some custom URIs for jars or something else. But what I can do then is essentially just say, what is my PySpark code? I want to execute this, and then what it will do is manage everything behind the scenes, including the creation of instances to execute the code, the actual code execution, the logging and error handling, and then ultimately, the spin down of those instances, and it's seamless to you as a user in that process. So once we have those executed, what's actually great about this, and for the sake of the demo, it takes about a minute to spin up the instances and then execute the code, so I won't go through that full piece. But what you can see is, we actually create a table here, and so we have our products, and then we could actually come and just query this table like anything else. And what this is doing behind the scenes is this is actually an Iceberg table that I have stood up in my data warehouse. And if we come over to our bucket, and click in. You can see here that I have my metadata. So these are JSON objects that essentially tell that table, okay, what are the actual files to pull in. And I have my data itself. You can see here, these are all of my different Parquet files that I have actually been creating over time in that process. So again, what we're essentially able to do in this, if you think of in your shoes as the Python developer, is we can bring what I'll call kind of like an arbitrary file format of data. So we work with the newest things like Iceberg, obviously Parquet, CSV, TSV, JSON, all those things. And then I'm also actually able to start bringing arbitrary compute to that data. So in this case, we could use our BigQuery compute, or we could use our serverless Spark compute. And what that really just enables for you is the choice to pick where you want your code to execute, and then to use the right platform for the right job in that. All right. So almost through here. Second to last thing we'll talk through is how we can then use our object tables. So here what I'm doing is, again, just using some simple SQL for the table creation. I'm creating a object table here. And then you can see here, I've done a quick specification here that this is a directory of object metadata, so I want all of the metadata about the directory. I'm pulling in data from this cloud storage bucket, and then what we can actually do is start looking at some of the things that are pulled into that. So let me go ahead and run the statement here. Here you can see what we've essentially done is pulled in every URI that exists in that bucket, and in this case, the URI is just the file location in the object storage. We have things like our hashes. We have things like when was the file last updated, and what we can actually do then is start to pass this into other things in order to do more analysis or work for that. And we're going to actually do just that here. What we're going to do is we're creating a table called vision detection. And what this will do, and we'll look at the code behind the scenes here in a minute, is that we're going to actually execute one of those remote procedures. And what this is going to do is it's going to actually send our data, or the components of data that we request in the function, out to a cloud function. We're going to have Python essentially organize and map how that data should then be transformed, and then we're going to return that back to our essentially materialized result set here as a result of that. So while that's running, what we can actually do is flip over, and you can see here, I've just created a simple Python function, but what this does is take in our request, and in this case, the request, because it's a function within the select statement, is a set of values that go in. We're going and actually calling the Vision API, and what this allows us to do then is to do things like annotate our images with additional information. So, one of the things that may be popular is, hey, I have images, like how do I actually know that there's like a logo or something in that if there's maybe concerns around that? This allows us to take all those pieces and then return this back to the BigQuery result set, store it in BigQuery, and then allow other users actually to access that, maybe in a dashboard or something else downstream. All right, so we can see our rows are there. What I'll go ahead and do is just go ahead and run a quick select off that. You can see here that what we've done is we've actually injected all of our metadata that was associated with an image. And you can see here that for one of the records, we actually identified that there may be personally identifiable information on this. So that's probably something we would want to look at and scrub depending on where this data was going. We also actually detected a face in this. And then we detected something with a car in that. So if you think about one of the big things now is obviously how do we keep data safe? There are a lot of ways here using different technologies that we can essentially make it very simple to identify where we may have potential issues in our data and really make sure that it's being governed in the right way for its use. And all of this is obviously accessible from BigQuery. So as you think about, how do I share that data downstream? We're not passing around files, right, on like a server, an object store. We're actually letting everything be managed via a set of role-based access controls in BigQuery, making it easy to share, but also making it scalable in terms of the sharing capabilities on that. All right, so a quick summary here. So first thing we started off with was, how do we build Pythonic-based data frames, and how do we actually execute those against BigQuery using IBIS? Can we also do the same thing using big frames and more of a pandas-like syntax? And then what we got into is, okay, how do we take that code, and then how do we actually execute that from BigQuery using something like PySpark, or using remote functions where we could run any Python that we wanted against our data and then get that result set back. So with that, really appreciate everyone attending today. And with that, I will pass it over to questions, and feel free to keep it open for anything Google data analytics related. The only caveat is I cannot talk about generative AI, which I'm sure everyone here loves to talk about. So, what questions can help to answer? Yeah.
So for the remote procedure call, is it shipping all the data to the function at once, or is it making a call for each row?
Yeah, so the question was, how does the remote procedure actually handle like record batching and other pieces in that? So are we shipping one like really, really big thing, or are we shipping one thing at a time in that? What happens behind the scenes is that we will manage the number of function instances that have to be spun up, and then we will start to parse that out. So let's say you have 50,000 records. We may choose behind the scenes that you only need one function to actually execute on that, or we may say, hey, we actually need to spin up 5 or 10 in that. We manage how those things have to be batched behind the scenes for you. So at the end of the day, what you experience is that the code returns the data that you expected, and you're not spending the time troubleshooting, like, why does the network hate me in that process? Does that help to answer your question?
Absolutely.
Yeah.
Is there a user case where you can connect to SAP HANA and make joins with another database?
Yes, so the question, make sure I cut it because I caught a little bit of the door in the microphone. Are there use cases where we can connect to and do joins based off data that sits in like SAP HANA and then materialize that downstream? Is that correct?
Yeah.
Yep. So we have a couple of things here. So one is that we have a actual framework called Cortex. And what that allows you to do is to connect to a number of different sources within SAP. I believe HANA is also one of them. And with that, you can then pull that data or replicate that data out of HANA into a tool like BigQuery, and then do what I'll call kind of like a co-location of that, and then do your joins, all of your other pieces with that. And I believe it also ships back, but that'd just be something that I would probably want to check in the framework component for that. But if you think, for a lot of our customers, like they'll use HANA and then something like Spanner or Postgres, which are two of our transactional relational databases, we can query those in place because we control the location and how the data works in that. And once you do that, BigQuery can essentially analyze any of that data and then send your results set back for activation to the SAP platform. Other questions? Yeah.
Yeah, it wasn't clear. So the remote functions need to run inside a cloud function. So when you talk about remote functions, can you clarify?
Yeah. Yep. So as it stands right now, remote function essentially runs in Cloud Functions or another technology called Cloud Run. And Cloud Run, for the technically interested, actually powers remote functions. It's our fully serverless stack for running containers. As it works right now, what happens is that you'll deploy the function and then it would execute on one of those stacks. Now, there's exploratory things where we're looking at how can we make that even simpler. So it's literally like you just tell BigQuery, here's the Python, and we figure out like even the underlying components. But right now, you would deploy that, and then the function or Cloud Run would execute that job. It's still relatively easy to set up. I do recognize in the deployment, it's one additional step because you got to ship that code to like Buildpack or something for that. Any other questions? All right. Well, thanks everyone. I hope this was useful for folks, learning more about BigQuery. I'll stick around here until obviously the end of the session if you have other questions that you'd like to ask. But really appreciate your time. Hope everyone here has a great day at the conference, and best wishes.